Okay, go ahead and write down this graph with this triangle. Okay, so today we're going to talk about special right triangles continued. So I'm going to talk about coordinate geometry this time. So we're going to use the same methods that we used yesterday, only now we have to find the sides of this triangle. So it says, find the measure of x. So we're looking for, this would be my theta then, right? Because that's the angle that we have that we're going to be concentrating on. So in order to find theta, we need to find the sides, right? So how could I find the sides of each triangle? Distance formula. Okay, so in order to find the distance of xy, I'm going to use the shortened version of the distance formula. Let's talk about how far I have to rise. Well, if this is my y-coordinate and this is my y-coordinate, how far is it from 4 to 8?
4.
1, 2, 3, 4. And how far is it from -6 to -2? 4. Isn't this 16 plus 16? Or, no. How about 2 16s, which equals 4√2. See, if you keep it simple, it's easier. All right, let's find YZ. No. YZ, how far do I have to go to get from 4 to 1? Down 3. And how far do I have to go over? 3. Isn't this 2 9? Which is 3 rad 2. I should be labeling this. This is 3√2. This is 4√2. And technically, I don't need the other side, but I'm going to do the other side just so we can double check our work. So if I want to find XZ, how far, let's travel on the x-axis this time. I'd have to travel over 1. And I'd have to travel up, how far is it from 1 to 8? 7. Which is 50, which is 25 times 2, which is 5√2. Not quite. All right, so which trig function would you like to use? We're trying to find this angle right here. So if we're trying to find this one, which one do you want to use?
YZ.
You want to use YZ? Okay, so check. We want that one. What other one? ZX? Okay. You know what? Instead of using, well, let's use this one over here because we can tell what this is really easily. I guess we can with this one too, which is just, it doesn't really matter. Okay, so if this is theta, we would call this the opposite, and we would call this one the adjacent. So which trig function would we be using? Would it be SO, COS, or TOA? If we were using opposite and adjacent, we would use TOA. So the tangent of theta is equivalent to opposite over adjacent. Correct? Everybody with me so far? That's what you guys chose to use, opposite over adjacent. So my opposite side is 3 root 2. And my adjacent side is 4 root 2. Well, that makes it nice, because these cancel. So finally, I know I need the tangent of theta equals 3/4. The tangent of theta equals 3/4. Does that look like 3/4? No. If you turn it into a decimal, that would be what? 3/4 is 7/500? That's still not an angle. So we need to use our tangent function to figure out this angle, which is our calculator. But hold on. I got to take you back to algebra for a second. You don't need to write this, but I do want to show you, because nobody ever showed me, and it's important to know where these things come from. All right, so forgetting this for 1 second, just pretend like it's not there. What do we do if we have a negative exponent? No, we don't multiply it by a negative. It's under 1, first of all. This is a negative exponent, right? An exponent means multiplying things. So what's the inverse of multiplication? And we want the inverse of -2. We want +2. So it's in the numerator, so where would I put it? In the denominator to make it positive. Not put it in the bottom. That's not what we do. We do the inverse. So what if I had 1 over x to the -2? What would that be? Then we would put x squared in the numerator. So that being said, brings us back to this. In order to solve for theta, that's what I'm trying to find, right? I'm trying to find that angle. How do you normally find things when you've got two things next to each other? That looks kind of funky, right? But do you see what I just did? I just divided both sides by tangent. When I divide both sides by tangent, the tangent goes away on this side, and I'm left with theta equals 3/4. Or if that bugs you, let's just do this. Over tangent. I have tangent in the denominator. How could I bring it up to the numerator? I just showed you over here. If I move it to the numerator, it becomes the inverse of tangent. And nobody ever showed that to me before. So, back to here. Hold on, we're not done. I'm just showing you why it works. So whenever you have something where it says the tangent of theta equals something, and you're trying to find the angle, all you need to do is say the angle is equal to the inverse of tangent 3/4. Okay? You don't have to do all that mess that I did on the last page. You just have to say, if I'm trying to find the angle, then I'm going to take the inverse of the tangent. You have to do the inverse tangent, and they're on most calculators. You've got a tangent, and you've got the inverse of tangent. No. So I'm going to pause this and do this on my calculator. Okay, so when I do that, I get, what did I get? About 36. Thank you. 36.8698. And that is this angle. Whenever you have these numbers, they seem to always want them drawn out that way, these angles. So it's a good habit to get into. Okay, so the last thing I want to do is I want to double check. So which would you like to double check with? We could double check with sine or cosine. Pick one.
Cosine.
Cosine. So cosine is cos, right? Which is adjacent over hypotenuse. So what's the adjacent measure? 4 rad 2 over what? 5 rad 2. So the cosine of theta equals 4 rad 2 over 5 rad 2. Cancel my rad 2's. So if you put in a calculator the cosine inverse of 4 over 5, what do you get? Anybody doing it? You get 38 point, or you shouldn't be, 36. Try it again. No, it's cosine. Inverse cosine. 36.8618. So it works, right? And you could put it in with the sine function as well. Okay, any questions? Okay, I'm going to show you one more thing. But as for the lesson, we're done today.